Okay, in this video lecture, I'm going to explain about the on-delay timer instruction in TIA portal. Okay, let's go to the TIA portal software. The on-delay timer instruction is listed under the basic instruction. In the right hand side, you can see under the timer operations. Here you can see the all the timer instructions are listed in here. Here you can see the on-delay timer. If you want to add this on-delay timer, you can drag it over here this way. Initially, it asks to create the instant data block. So that means it creates the data block to operate the timer. So that means the data relevant to the timer, particular timer, is stored in a separate data block. So you can give any custom name for the timer instant data block. So I'm going to give timer 1, the data block, the name, click OK. The under the system block and the program resources, you can see the created timer instant data block. Here you can see its data are listed in here, the preset time, elapsed time, timer enabling bit, and timer output bit. Okay, these are the data stored in timer instant data block. Okay, before we are going to use this timer, let's go to the help view of the timer. Okay, go to the portal view, they go to the help. Here I'm going to type basic instructions. Yeah, ladder instructions, the time operations, on delay timer. Here you can see the description of the on delay timer, the displayed under the help view. Okay, then this is the one, this is the important one. You can see yeah. Okay, in here you can see uh, input bit, timer enabling bit. This is also called the timer start bit, timer enabling bit. When the power flow reaches this input, timer start its timer counting. When the timer current value, that means the timer elapsed time, reaches the preset time, it gives output from the queue. Output timer bit is set. It gives output from the queue. So the preset time, that means the timer we are given to the timer is called the preset time. Okay. So then using this timing diagram, you can clearly understand the operation of the timer. You can see the timer enabling bit. When the power reaches to the input port, timer start its counting. Timer counting. You can see the timer current value, the increases. When it reaches to the threshold, the preset time, the time that we are given to the timer, timer get overflow. You can see the timer bit. At the same time, the timer bit is set. You can see timer bit is set. It remain until timer enabling bit is high. When the timer input bit goes low, you can see timer current value goes to 0, and also timer bit also goes to 0. That means the timer reset. You can see in this situation, you can see the short pulse to the timer input bit, that not able to trigger the timer. The timer at the positive edge of the enabling bit, it also increase the timer counting, but timer not reaches to the threshold value, the preset time. So no output from the queue. Then again you can see another positive edge. The timer is start its counting. When the timer reaches the preset time, timer overflow bit set. You can see it gives output from the queue. Then when the timer input bit goes 0, you can see the timer bit, the timer output bit also goes to 0, and the timer current value also reset to 0. This is the operation of the timer. Okay, using this timing diagram you can clearly understand the operation of the timer. Okay, let's write the simple program and see uh, how it works. Okay, this is the timer we use. Let's take the timer enabling. We are going to done using the memory bit. Let's take m 0.0. I'm going to use the memory bit, so I'm going to rename the tag start change. Okay, then preset time, the double click to give the preset time. If you are giving the number alone, it will take as the millisecond. So other way you can give it as the number, and if you type the s, it take as the 5 second. Likewise you can give the preset time, the time that require for delay. Okay, then the time output, the time output you can take from the queue on the same branch. So you can give any queue 0 0.0. Let's take the bulb. Yeah, let's rename the tag bulb. Okay, this is our simple program. This time output bit also you can use in a separate network as well. So let me show that one also. Okay, let me erase this one. So if you want to use it in a separate network, if you want to use time output in a separate network, you can do that one also. So let me show that one. So let's take this one as the bulb. Yeah, so then this one, that the timer bit, you are going to select it from the timer instant data block. Here you can see the time instant data block. In a timer instant data block, the queue we are going to select, timer output bit we are going to select the enter. You can see the timer output, time output bit is set. What happened, there's a power flow to the bulb. Okay, let's compile the program and run. Okay, program has compiled, no errors. Okay, let's run the program. Start simulation, click OK. Okay, it opens the PLC sim software. Okay, let's minimize this one. So the connect, you're going to virtually connect this TIA portal with the PLC sim. Here I'm going to load the program. So then I'm going to start the module. Okay, let's monitor input outputs. Click here. Yeah, initially you can see there's no power flow to the timer here. This is in low state. So what happen if we change the state of the m0.0? So I'm going to modify to 1. Here you can see timer start is counting. Yeah, let me show that one again. The modify 0. Okay, modify goes to 1. Here you can see timer start it's counting the 2 second, 3 second, 4 second. So then you can see the timer bit is set. You can see at the same time this bit goes high and there's a power flow developed to the bulb. So then what happen if we set the timer input bit to 0? Yeah, the both goes to 0. Timer, the timer current value and also the timer bit also goes to 0. So let me further show it by tracing the outputs. So I will show the timing diagram. Okay, that means that we can get the timing diagram by tracing the output. So we are going to trace the outputs. You can trace the output using this command, the traces, add new traces. Double click. This is the initial window. The first of all, you have to define the signal that you want to trace. The signal I want to trace, yeah, you can select it from this from here. I want to trace timer output bit, this one, and also the I want to trace timer current value also, timer elapsed time also I want to trace here. Okay, these are the two parameters we want to trace. Okay, then let's go to the sampling. So sampling with the main programming, record every cycle. So I'm going to select the 100 cycles. It's a millisecond time cycle, so I'm going to select the record every 100 cycles. Okay, recording duration, yeah, let's take 40327. Okay, okay, here I'm not going to use any trigger for this monitoring. Yeah, that's all. These are the things basically you have to set. Okay, let's transfer configuration to the device. Okay, okay, let's activate recording. Okay, first let's open the main block also. So let's start input output monitoring. Let's split the window. This is our main program. This is our trace, the graph of the trace. We can get the uh, timing diagram in here. Okay, okay, let's modify to 0. Then here you can see, yeah, then let's what happen if we modify it to 1. So you can see the timer is counting, you can see. Then when it reaches to the 5 second, here you can see the 5-second value, the timer bit is set, you can see. When it reaches to this point, you can see at the same time the timer bit also set. The, okay, so then what happen if we modify this to 0? That means what happen if we disable the power flow to the timer, the both goes to 0. Timer current value also goes to 0. The timer output bit also goes to 0, you can see. So then let's modify. So before reaching to, yeah, you can see before reaching to overflow, so I reset the input. You can see timer not trigger because it not reaches to the preset value, preset time, you can see. Okay, this is how we are using the trace command to observe the outputs. Okay, I think you all got a very clear idea how to use the on delay timer instruction in TIA Portal software in programming the PLC. Okay, thank you. See you on next TIA Portal lecture.